Okay, so we're studying logarithms. We've talked about earthquakes and how to locate them, correct?
Yes.
Using the seismic data and circles. Well, here's another way to measure earthquakes. This is, let me get rid of my screen here. Okay, this is the United States Geological Survey website of all the worldwide earthquakes in the past day. They keep track of all of them. It's pretty cool, actually. So, what you see is the map. Okay, we're like right here, right? Okay, here's the Pacific Ring of Fire. Notice that most of the activity is there. This tectonic plate moves a lot. Okay, that's why there's so many earthquakes along the boundary here. The biggest one of the day, the last 24 hours, I think, was in Indonesia. It's a 5.0. There was a 4.9 in Japan. The size of the dot means a bigger earthquake, and you can get the number over here. You can click on it too. I'll put it down in a sec. There was probably about a 4 in Alaska there. It was, yeah, a lot of activity in there. We had some pretty good earthquakes while we lived there. It was volcanoes blowing up. We got ashed by a volcano. That was pretty cool too. Not really, but.
It's not.
Okay, does anybody know what state that is? You're not in Kansas anymore. You're pretty close though.
Very.
It's Oklahoma. Oklahoma is the #1 earthquake center in the world right now.
Well, it's like 3.
For quantity.
No, it's like 3.
Why? That's a great question. Does anybody know?
It's tornadoes.
It's not tornadoes. Okay, the theory is it's fracking. Yeah.
So it's like
Basically, they're fracking the rocks, putting liquid in there.
shifting your.
When after they use the fracking fluid, they have to dispose of it. Well, we drill injection wells. So they use old oil and gas wells, and they inject the water back into them. The theory is that that's lubricating fault lines, causing them to slip. So they're getting more numerous, and they're getting bigger. Yeah, there was one in Oklahoma City last week, like literally under Oklahoma City, earthquake, 4.0. Bam. Okay, so what's the point of me telling you this? Yeah. How do we know what the difference between these numbers is? A logarithm. Yeah, it's a logarithmic scale, right? So what's the difference between? We've mentioned this. The 4.0 in Langston, Oklahoma, and the 5.0 here in Indonesia. Oh, that's a good question. Well, that's better. What's the difference between a 4.0 earthquake in Oklahoma and the 5.0 earthquake in Indonesia? 1.0. One bigger? Yeah. You sure?
Yeah.
It's a logarithmic scale. This is actually a factor of 10 bigger. Has anybody ever been in an earthquake? Yeah. You've probably been in a 3 or a 4, right? It rattles, it shakes for 5 or 10 seconds. Great. Now imagine something 10 times more powerful. Okay, it really rocks and it really shakes and it might last 10 seconds. Okay, it's really fun, but then you jump to a 6. A 6 is 100 times more powerful than a 4. How's that happen? Then what's the next? A 7, it's 1,000 times powerful than a 4. An 8, 10,000, then 100,000. Anybody know the most powerful earthquake ever?
12.9.
No, it isn't that big. Cool, we got that one destroyed. You're close. It was a 9.5 in Chile in 1960. Alaska had a 9.4 in 1964. The 2 biggest ever. So, FYI there. So again, if you want, you can click on these, and it brings up the information. Oh, that was probably the most recent. It just happened. 3.2 in the British Virgin Islands.
Remember the British and the French and the Spanish had their little wars about this region here in the Caribbean? Yeah, back in the days of exploration and colonialism. Right, so there's your intro to logarithms, okay? It's a power of something. Okay, I'm gonna put a 10 here. That's what we're gonna look at. So if you have an exponential, this is actually, so an earthquake of power of Richter scale 4 has 10 to the 4th, I forget the units of measure, amount of energy, given as 10 to the 5th, 10 to the 6th, okay? We don't say, oh, that earthquake was a 10 to the 5th, right? We say it was a 5. So we're basically taking a logarithm, and we're taking a logarithm of that base. Make sure I write it down. The base is the base. So. So if our earthquake is a 5, right? The log base 10, this is the amount of power, so it's 10 with 5 zeros. So this is what it would look like. You know that this is 10 with 5 zeros, correct? There's one way to write it. Sorry, no, this is not right. That should be fine. You can also write it like this. See how these cancel each other out? So what you're seeing here is that exponentials, what do we do here? We switch the x's and y's, right? So what do we call that? Yeah, they're inverses. So when you got a Richter scale of 5, we know that the power of that is 10,000 units. We take the logarithm of that base 10, and it gives us our Richter scale value. It could be, I don't know. It might even be like megajoules or gigajoules. I mean, they're big. Think about that mountain rubbing against another mountain. How much energy that's gonna create. Okay, remember, if you want to do tables, you can also. Okay, this is x, y. If I'm using this function here, that's 1/10. That's 1, and that would be 10, right? So the logarithms, the inverse. So we switch the x's and y's. Let's look at it. So you're going to be transferring between exponentials and logs. And I'll show you a couple of those, and then I'll help you. Then we're going to just do some calculations with logarithms. So it's basically an arithmetic day. So let's look at. Let's write these equations in exponential. This is going to be base. 125. So you practice writing it as an exponential. You got to transfer back and forth. It helps a lot to think of these in terms of exponentials. So what's the base? 125. That's the base. And what's the exponent going to be? This one. Yeah, 2/3. And then that equals. So we're rewriting. This obviously, I think you're a little more attuned to exponents, right? 125 squared, the cube root. Remember with these big numbers, I advise you to do the cube root first. So the cube root is 5. What's 5 squared? 5. Good. So that's how we rewrite them. Do you see another, or are you good there? Let's try this one. I'm going to rewrite it on your own. We'll check your answers. Log base 16/4 equals 1/2. Survey says 16 to the equals, yeah, square root of 16, right? Cool, okay. Write this. Log, we're using a shorthand, so I don't have to write logarithm every single time. Again, base stays the same. And then you switch.
But this thing that, if you look at like 4 by itself,
Yeah, you can rewrite this if you wish. 64 is 4 to the 3rd power. 4 times 4 times 4. Logarithms are basically saying, what exponent do you need to get 64? That's the answer. We're looking for that exponent. Here's another one. Yep, root of the negative, that should be -3. That is something to look right. Root of the -3 is 27. Rewrite it. So you got some practice. Switching back and forth. You got to be able to think in terms. One of the biggest concepts you can
know cold in math is the concept of inverses. You use it to solve equations, right? Let's see, how do I get the 3 over here? Addition, right? Those are inverses. How do I get the 2 over there? Division. Multiplication and division are inverses. It's not usually taught that way, but it's the same concept. You're solving equations using inverses. Can help you solve equations. So, without a calculator even. Your calculator has a handy dandy logarithm key that we'll use quite a bit. But let me show you one. Here's x equals log base 7 149. There are a couple ways you can manage these problems. Tomorrow I'll show you some properties of logarithms that help solve this a little bit. One way is to switch it to an exponential. So that would be 7 to the power of x is 147. Now we just need to get this as a power of an exponential 7. With base 7. 49 is 7 squared, right? And then how can I edit that to make it like this one? Using our properties and powers. So what's that? So we're trying to get the bases the same, so the exponents match up. That's one way, using exponentials. The other method would involve just editing the logarithm using the properties, using your logarithm knowledge. So here's method 1, here's method 2. We know, and we've already established 149 is 7 to the negative 2, right? We've already established that. So this would mean, those are inverses, so they cancel out this, right? So using your knowledge of logs to solve it. I don't care which way you use, if you pick, but either one works. So we'll throw those mainly at you where they're nice, pretty bases at first. Okay, but we'll start doing changer bases. Right. We can use them to solve exponentials as well. Let's do this. Here's an equation. This is actually a work problem in the book. It's dealing with half-life of thorium 234. So we're starting with 256,000 grams. Half-life is 25 days. And how long does it take to decay to 1,000 grams? This is a chemistry question. Okay, how many of you are in chemistry? You haven't really despised it yet? It's really hard. AP chemistry is really hard. I didn't even enjoy regular college chemistry, so it's really good stuff. So we gotta solve this equation. So we divide 256 over it. What is it? 1 over 256. Okay, so so you could think exponents of 2 here, right? To solve this. This is how I did it, 2, 4, 8, 16, 32, 64, 128, 256. There's my answer. Right? So I just counted, I doubled every time. This powers of 2. 2, 4, 8, 16, 32, 64, 128, 256. Right? 256 is 2 to the power of 8. Right, so T has to be 8. Okay, there's one way to do it. If you're proficient at counting by the exponents of 2. Very handy, by the way, if you can, for calculus purposes. The other way is to rewrite it as a logarithm. So this is method 1. Here's method 2. Using your log knowledge. And again, it's the same concept here. Try to write it as a power of 8. That you can also write like this, because 1 to the 8th is 1, right? So you can rewrite it this way, and then we know our answer is 8, right? So using logs or using exponentials to solve this equation is either one is good. Right? I'll hold on, so any questions? The main thing here is get the relationship, be able to rewrite them. Okay? I want the big idea of what logarithms are in your brains. Tomorrow we'll talk about manipulating them. This is what addresses today's work. If you want to start there, you can. You can work on 11.3 as well. But this is day 1. Tomorrow we'll talk about everything else. Maybe that would be the day 2 stuff. This is all going to be due Tuesday. And then spiraling. You want me to keep adding? Okay, number 77 has a degrees, minutes, seconds. Again, I teach you that, so there's your decimal for that. So you can get some practice here.
So 11.3 or 11.4, your pick, but I gave you plenty of time to work on those. So make me come over there.
Enjoy. Third, that's thanks for asking.
Some people have 35 and
What was that? 105.3.
105.3.